this lecture, we are going to see about transistors. And as you know, transistor is a semiconductor device and got its name from the word transfer resistors, right? So transfer resistor. So we are transferring a signal or input current from a low resistance circuit to a higher resistance circuit. For example, this is input signal or current that has to be transferred from the low resistance circuit to the higher resistance circuit, right? So it follows a low resistance high resistance path. In this video we are going to concentrate more on the NPN transistors, and in the next video we will be concentrating on PNP transistors, right? NPN or PNP transistors are nothing but PN junction diodes connected back to back, right? Like this. They have three layers, PNP, right? So each layer will be having its own significance. So PNP, and we have two junctions here. Junction 1 between N and P, and junction 2 between P and N, right? So this NPN transistors and PNP transistors are nothing but junction transistors, right? Junction transistors. Why? Because the transfer occurs in these two junctions. That is why, right? Here in PNP and NPN, both transistors, you can have the majority and minority charge carriers that are moving against the junction voltage applied, right? So here we can observe that both electrons and holes, they constitute to the flow of current, right? So electrons and holes, they constitute the flow of current. So that is why both the polarities are in charge of the flow of current. So you call it a bipolar junction transistor, and shortly we call it BJT, right? So the BJT is a three layer, and this BJT is a three layer and two terminal device, right? I'm just changing the color, please wait. It is a, please note down, these are the key points you should be remembering. So three layer, three terminal and two layer device. So first layer is the emitter. The duty of the emitter is to emit charges. In case of NPN transistors, the emitter emits electrons, and in case of PNP transistors, the emitter emits holes, right? So in general, the emitter emits charges. It may be hole or it may be electrons, right? These emitters are heavily doped, right? So they will be given with lots of impurities, so that we want maximum number of charges to be emitted from the emitters so that they can release more number of charges. So we are doping them heavily, right? The second one is the collector. The duty of the collector is to collect the charges emitted by the emitter. Collect the charges emitted by these emitters, right? So since they need to collect all the charges, they will be moderately doped. They are doped, but they are not doped as heavily as the emitters. The last one, or the base, is the base. Actually only one base is available. So the duty of the base is to control the flow of charges between the emitter and the collector, and the size of the base is thin, and it is very lightly doped, right? It controls the flow of charges, so they are very lightly doped. So this is how I'm just drawing here a basic figure of NPN transistor. So this is how it looks like. This is the base, and emitter, collector. I can see this, right? So emitter is injecting, or I mean it is emitting electrons. So this is NPN configuration, NPN, right? So this is a PNP configuration, and now you can see the difference between these two. In PNP configuration, the emitter is injecting the holes towards the base, right? In this video In this lecture, we'll concentrate more on NPN configuration, and in the next video, we'll be concentrating on PNP. This is NPN transistor, and as you can see, the NPN transistors have three layers, as I already mentioned. So this is the emitter side, E, and this is the base, and this is the collector, right? So this is the junction 1 between N layer and P layer, J1, and this is the junction 2 between the P layer and N layer, junction 2, right? I'll draw the symbol once again. So whenever you are asked to write a theory about NPN transistors, please draw this figure on the left, and please draw the symbol, a representation of NPN transistors, right? So this is how it looks like, right? So what happens? Let's see the operations of NPN transistors first, right? The emitter in NPN transistors are nothing but the N layer, right? So duty of the N layer is to emit electrons, lots of electrons. So they are heavily doped, and you can see lots of electrons here, and the size of the N layer is very big compared to the size of the other two layers, right? So B is nothing but the base, right? So the size of the base, as you can see, so the base is doped with P layer. The size of the base is comparatively very small, or in some textbooks they will be mentioning it as very thin, right? So it is very lightly doped, so it will accept electrons. So in the N layer here is nothing but the collector. It is not free of electrons, it will be having electrons, but the density of electrons is lesser compared to the emitter, right? So this is how this is the construction of NPN transistors. Now we'll see the operation here. So when you apply voltage to this, so this three layers, the first two layers will be looking like a PN junction diode, right? So we are giving forward bias to this PN junction diode, right? So forward bias. So whenever forward bias is applied between the emitter and the base, so it is called VEB, and this is the potential applied between the base and the collector, VBC, right? So I'll come back to this. So this is N layer and P layer, and looks like a PN junction diode, and you are giving a forward bias to it, right? So whenever you are giving forward bias to it, this PN junction diode will start conducting forward bias, right? So this positive potential here will attract electrons from the N side, right? So these electrons will be now attracted towards this direction, right? And because of the negative potential here, the current will be flowing in this direction. That current will be IE, current from the emitter, IE. I'll just rewrite this, please wait. Right, so this is IE, and now you observe this is this layer, the minority charge carriers here will be also moving, right? So this will be constituting a current IB in the base because of the movement of the holes, right? Now just consider this voltage VBC. So this VBC is in reverse bias. Why? Because this P layer and N layer, I'll just erase all this, please wait. Sorry for the trouble, just erase this for your attention, right? So this is a P layer and N layer, and this is also a PN junction diode now, right? This PN junction diode is now reverse biased, right? VBC is given as a reverse bias voltage to this PN junction diode, reverse bias, right? So this reverse bias, so there is a potential applied here is VBC. This VBC is bigger compared to VEB, right? The reason why VBC is bigger compared to VEB is the higher the positive potential here, more electrons will be attracted towards the collector, right? So if the positive potential of VBC is very high, it will attract lots of electrons from the emitter, right? So some electrons, some current will be passed as IB, and more current will be passed through this collector, right? So that is why this voltage here is bigger. That means VBC is bigger than VEB, right? Because of this movement of charges from the emitter to the collector, a current will be constituted, and that will be IC, right? IC. Now we'll write an expression for this. So IE is nothing but, according to Kirchhoff's current law, IE is equal to IB plus IC, right? Our duty is to keep this IB as minimum as possible, right? So the duty of the base is to control the flow of charges from the emitter to the collector. That means to control the reactions between IE and IC, right? So for ideal transistor, for an ideal NPN transistor, in ideal conditions, IE is equal to IC, right? Practically it is not possible because there will be a small value of IB occurring here, right? You cannot ignore it, but it can be negligible. You can make it small, right? So this is how an NPN transistor works. In the next video, we will discuss more on PNP transistors. So if you have any doubts or clarifications required, please put it in the comment box, and thanks for watching.